Good afternoon, children. Good afternoon. Good afternoon, children. Very good afternoon. Good afternoon. Very good. Good afternoon. Good afternoon. Okay. Yeah. Good afternoon, beta. Good afternoon. Yes, now we are starting now. Good afternoon. और ऊपर कर दो उसको. You make it more up so that we can read more. Yeah. Thank you. Yeah. Good afternoon, children. So I am audible now. I am very much audible. यहाँ पे नहीं आता. यहाँ पे कोई join नहीं करता. Participants only. We are the participants. 5 came and they're gone. Okay. Okay. And here. Okay. Dear children, please tell me what was the last thing I was discussing yesterday. We discussed quite a lot, and also I have seen people have shared those, slides of the classroom, of the class. Okay. So can you please record? Yes, we are recording every class. We are recording every class. Pulmonary and systemic heart. Very good. Thank you for reminding. We are recording every class and we are also uploading them. We are uploading, every class is uploaded on the YouTube also. So if you go to the channel Shri Gosalites, you will find that uploaded there. Yes, please, circulation of heart, of mammalian heart. Recording of this class isn't started. Recording of this class, yeah, we are recording in a different system. Okay. Dear children, today I will discuss a little different topic because as people said, I have to discuss the cardiac cycle and all. Well, very quick idea about the cardiac cycle, and then what I have planned for today's class is a different topic. Okay. So cardiac cycle, there is a heartbeat. You heard about the heartbeat. All the events that occur in the heart, from the beginning of one heartbeat to the beginning of the other, all the events that occur in the heart, from the beginning of one heartbeat to the beginning of other. Just try to think. Did you understand this? All the events that occur in the heart from the beginning of one heartbeat to the beginning of other constitute a cardiac cycle, because what happens that these are cyclically repeated, and thankfully they should repeat cyclically also. Otherwise, you understand what can happen if they don't repeat. If these events don't repeat, then you understand you cannot survive. So these are cyclically repeated, beginning of one heartbeat to the beginning of the next constitute one cardiac cycle. So to show this cardiac cycle, let us see, I have shown it by a circle because these are cyclically repeated. So whenever you have to make the picture or the diagram of this one, you can draw like this. Okay. So let's prepare one. Let's divide it into two parts like this. From the center, make a small wedge. And this is the cardiac cycle. All the events in the heart, this represents the cardiac cycle. Okay. So what are the events that occur? Let us see, we begin the cardiac cycle from here. Let us say the SA node, which is the pacemaker of the heart, has fired. As I told you that you already know that we have chambers called atria and ventricles. Atria, they are the smaller one, upper one, and ventricles, they are the bigger one and the larger one. We are aware of them, right? I told you that auricles and atria are two different things. Auricle is the extension of atrium. Atrium is the main chamber. atrium, and the plural of atrium is atria, ventricle and many ventricle, ventricles, atrium, atria, bacterium, bacteria, millennium, millennia, datum, data, cilium, cilia, flagellum, flagella, stadium, stadia, millennium, millennia. So these terms which end with so they become a as plural. So all what I spoke just now, all these are the plural forms. Okay. Yes, Greek, Latin words. Very good. So dear children, what are the events that occur during the cardiac cycle? Okay, first of all, whenever I say systole, I mean the contraction phase. Systole means the contraction phase, and diastole means the relaxation phase. Systole, contraction, diastole, relaxation. Systole, very good afternoon, beta, good afternoon. Very good afternoon. Systole, contraction, and diastole, relaxation. One contraction of auricle and one contraction of ventricle. Okay, good. So not only contraction, but also relaxation. And in one heartbeat, you know what happens? Atria, they contract and relax, systole and diastole, and ventricles, they also complete their systole and diastole. Again, listen, in one heartbeat, atria, they complete their systole and one systole, one diastole, and ventricles, they also complete one systole and one diastole. But you should remember that when atrium or atria are in systole, at that time ventricles are in diastole, and when ventricles are in systole, at that time atria are in diastole. Ante there is no joint diastole. There is no joint diastole, right? Again, listen. When atria are in systole, ventricles are in diastole, and when ventricles are in systole, atria are in diastole, right? Until there is no joint diastole, there is no joint systole. Joint systole is not there, right? Joint diastole may be there, will be there, is there, but joint systole is not there. One more important point before starting this, systole is contraction phase, pressure rises in systole, and diastole relaxation phase, pressure falls in diastole, right? Now, you know that if I just contract something, if I have taken, balloon and there is an air in the balloon and there is some pressure of air in the balloon, right? Now, if I just squeeze the balloon, because the pressure rises, a time comes that the balloon bursts. Why the balloon bursts? Because the pressure rises, right? In the same way, when any chamber relaxes, the pressure inside it comes down. When it contracts, the pressure rises, and when something relaxes, the pressure comes down. Now you will understand this. This is Boyle's law. Guys, this is called the Boyle's law, okay? Subtitles. What subtitles are, beta? Could you stop subtitles? Sophia, you have to tell me where are you seeing the subtitles? You have to tell me. Acha, this one. Oh, sorry. It is confusing for me also. You have to tell. Okay. How to? How to do that? Because it is disturbing for me also. Thank you for telling me this. How to do that? Closed caption. We did that. It's so light, not visible. Is it coming now? Is it gone now? Gone? Closed captioning. Okay. Is it still coming? It's still there. It is very disturbing. It is disturbing for me also. And that's the reason, you know, I was also getting distracted. Brother, captioning आ रहा है, captioning को डिसो करो. Click on live transcript. Live transcript click करिए. Live transcript. Yeah. We have done that. So we have clicked now. अच्छा, ठीक है. Chat participants has joined.
Stop, sir.
What is this? Description. Stop, stop. Okay. Disable auto. ठीक है, इसको disable कर दो. ठीक है. Is it fine now? Recording, we are doing it in a different computer. But that transcript has gone now. Oh, very good. Shalia. Okay. Thanks for telling, because it was really very disturbing for me also to see that. Very good. So I was telling you, during systole, I was discussing about the Boyle's law. I was discussing about the Boyle's law, that the pressure and volume are having inverse relation. As the volume increases, the pressure decreases. As the volume decreases, the pressure increases. Okay, done. So whenever the pressure increases, what will happen? Whenever the pressure increases, the blood is pushed out or pumped out. And when the pressure decreases, blood enters. When the pressure is increasing, the blood is pumped out. And when the pressure decreases, the blood enters. Make sense? Got it? Okay. So when I say that there is atrial systole, if I say there is atrial systole, what does this mean? It means that the blood has pumped out from atria. And when I say ventricular systole, the blood has pumped out of the ventricles. And when I say atrial diastole, that means atria are getting filled. And when I say ventricular diastole, I am saying ventricles are getting filled. Make sense? So this is the thumb of rule here, that systole means pressure is increasing, and diastole means pressure is decreasing. Okay. Also remember that when the systole occurs, the blood is pumped out. And when diastole occurs, so it leads to blood filling. Blood fills in. Okay. So blood fills inside. Okay. When the systole occurs, blood is pumped out, and in diastole, the blood enters into the chamber. So in systole, blood exits from the chamber. In systole, blood exits from the chamber, and in diastole, blood enters the chamber. These points are clear to you? All these points we'll come to this once again. I'll go to the next page. Another point to understand here is that the direction of blood through heart. The direction of blood through heart. You know that there are great veins. These great veins open into the heart. So the great veins, they pump the blood into the atria. Right? Atria can pump the blood into ventricles, and ventricles can pump the blood into great arteries. great arteries. They can pump the blood into great arteries. I hope you understand great veins. Great veins are the vena cava and the pulmonary veins. Great veins are the vena cava, C-A-V-A-E, because there are two vena cava, vena cavae and pulmonary veins. Pulmonary veins. And when I say great arteries, I am saying the pulmonary aorta, and systemic aorta. Pulmonary aorta and systemic aorta. Okay, I can also call it trunk, pulmonary trunk and systemic trunk. Pulmonary trunk and systemic trunks. These are the great arteries. Now, also remember that the blood never returns back into the veins, right? So from the atria, the blood does not return back into the veins. Atria, the blood does not return back into the veins, okay? From the atria, there is no returning of the blood. This does not happen, right? From the atria, return of blood is not possible. From the ventricles into atria, this is also not possible. And from the great arteries into the ventricles, this is also not possible. So the right direction is this only. The return is not possible. Can anyone tell me what is the reason why the blood cannot return back into the great veins? I know it is a little difficult for you people. If you can answer me why the blood does not return back into the great veins. Okay, we'll come to the difficult one later. First, let me answer. Okay, just let me get the answer why the blood does not return back into the ventricles. What prevents the return of the blood into the ventricles from the great arteries? What prevents the return of the blood into the ventricles from the great arteries? Whenever ventricles are in diastole, the ventricles pressure go down and the ventricles can get the blood. Why can't they get the blood from the great arteries? Come on, come on. What is that? Very good. There are valves, presence of valve. Perfect answer. The valves are there in the valve's name. The valves are there and the valves are known as the semilunar valve. Okay. So there is a pulmonary semilunar valve. Pulmonary, and there is something called systemic or aortic. Pulmonary and aortic semilunar valve. Semilunar valve. Pulmonary semilunar valve is on the right hand side and aortic semilunar valve is on the left hand side. Pulmonary SLV on the right side and aortic on the left side. I mean to say pulmonary semilunar valve is at the beginning of the pulmonary trunk and aortic semilunar valve is at the beginning of the aortic trunk or aorta. In the same way, from the ventricles into atria, what prevents the re-entry of blood into the atria? When the atrial pressure is going down, what prevents the re-entry of blood into the atria? Come on. Very good. Very good. These are known as the atrioventricular valves. These are called atrioventricular valves. Atrioventricular valves. For example, there is a tricuspid and mitral valve. Tricuspid and mitral valve. What prevents the re-entry of blood into the atria from the ventricles? Tricuspid and mitral valve. What prevents the entry of blood into the great veins from the atria? Atria into the great veins. What prevents the entry of blood into the atria from the great veins? And remember, there are no valves there. There are no valves there, beta. Valves of vein, Divya. Yes, Divya. Very good. Valves of the vein. Very good. One of the reason is internal valves. Internal valves. internal valves in the veins, in veins. One of the reason is internal valves in the vein. Another reason is oblique openings, oblique openings, oblique openings. Another reason is oblique openings of the great vein into the wall of atria, oblique openings of the great vein into the wall of atria. I hope you understand. So these are the two reasons why, although there is no vein, there is no valve at the beginning of at the opening of the veins into the atria. At that opening, there is no valve. Okay, done. So I hope you have understood. And if you want to just have a look at all these valves, okay. So for that, I'll draw a diagram, or what should I do? To make it faster, I can download also. Rather than making this again and again, I'll download one. Okay. So anyone who know why the bicuspid valve is also called mitral valve? What is the meaning of mitral? Anyone? What is the meaning of mitral? Why the bicuspid valve is also known as mitral valve? Bicuspid valve is also known as mitral valve. Okay. So I'll show this one is good. Now this one is giving the right picture of this valve. So I'll first open this one. Oklahoma. Okay. Dear children, you can see this one. Here you can see. So let us see where is the right atrium. Right atrium, left atrium, right ventricle, left ventricle. From right atrium to right ventricle, this valve, this is the tricuspid valve. Between right atrium and right ventricle, tricuspid valve. Three cusps are there and therefore tricuspid valve. I used to call them as the Mercedes valve. I call them Mercedes. It looked like a symbol of Mercedes, therefore I call them Mercedes valve. Come on. Then from the right ventricle into the pulmonary trunk, right ventricle into the pulmonary trunk, and here is that one, this one, this one, this one. The complete picture is here. This is a pulmonary semilunar valve, pulmonary semilunar valve, pulmonary semilunar valve. And the reason we call them semilunar, because when you see the picture from the side, it looks like half moon. It exactly looks like half moon here, because they have done it shading, therefore you're not able to see it right now, but then it looks like half moon. Guys, now this is the left atrium and left ventricle. Between the left atrium and the left ventricle, this is the bicuspid or the mitral valve, and this is the left ventricle and the aorta, the systemic trunk, and this is the aortic semilunar valve. The complete name is aortic semilunar valve, and that is a pulmonary semilunar valve, mitral valve, and tricuspid valve. How you can remember that mitral is on the left hand side? Remember please, mitral has a L there. In mitral, there is an L in the mitral. Okay, so mitral has an L. Okay, so L means left hand side. L means left hand side, so it is between the left atrium and the left ventricle. And why it is called the mitral? You can see the picture. As if someone is wearing, you can see the cap worn by the bishops, the cap worn by the bishops. And you are watching, you are seeing that from the top, right? So this is the top view, or precisely known as the, what do you call that? Drone view. It is a drone view. From the drone, if you see the cap of the bishop, cap of the bishops, right? You can see this type. So that is called mitra. This cap is called mitra, and therefore on the name of mitra, the name becomes mitral. So mitral means looking like a cap, and the cap worn by the bishops. Okay, guys, so these are the four important valves. And at the opening of the great veins, at the opening of the superior vena cava, inferior vena cava, pulmonary vein, there is no valve. Valve is not at the opening, valve is inside. Valve is inside, you understand, right? Internal valves are there in the veins, and moreover, these are oblique openings. So whenever there is a contraction of the atrium, see, when the reason of entering the blood is when the atrial pressure increase. When the atrial pressure increase, atria are in systole. And because the oblique opening is there, when the atria are in systole, these oblique openings become further closed. So whenever any tube is opening obliquely into a chamber, when the chamber contracts, that tube opening also contracts, and this itself acts like a valve. So there is no separate valve or valve here, and that oblique opening itself acts like a valve. Another thing is the internal valves are there in the veins. Veins have internal valves. Okay. We can refer to that picture again and again. There is another beautiful picture, if you can see there. Another beautiful picture, which you have to go back here. Let's go to the browser. Yeah. Leaky valve. This one. And this one. Now you can see one more thing, and if you can understand this one, and really means half or more than half of the battle is won. This one, see. The first picture, the left-hand side is during diastole, and the right-hand side is during systole. In diastole, remember that the pressure inside the chamber is low. And when we say diastole of the heart, when it is not written which diastole, whether atrial or ventricular, we always mean it is a ventricular diastole. So I should write it ventricular diastole, or you can understand it as a ventricular diastole. In ventricular diastole, the blood is filling into the ventricles, and for that, and where from the blood comes into the ventricle? From where the blood can come into the ventricle, it can come from the atria. And in that time, there is opening of the atrioventricular valve. You can clearly see that this is a tricuspid valve open here and the mitral valve open here. So ventricular pressure is low, blood is filling in the ventricle, blood is filling from the atria. This is the right-hand side. In the left-hand side, you can understand that the right-hand side has the deoxygenated blood and therefore blue color, and the left-hand side has got the oxygenated and therefore the red color. So at that time, when the blood is filling into the ventricle, the atrioventricular valve is open, right? This is open. And the blood should not come from the great arteries. The blood should not come from the great arteries. And that is the reason these are the semilunar valves. These are the semilunar, pulmonary semilunar, and the aortic semilunar are closed. Pulmonary semilunar and aortic semilunar are closed. Now, during the systolic phase, in systolic phase, what is happening? There is a high pressure of blood in the ventricles. And the ventricle blood wants to go, tries to go everywhere, all around. When the blood tries to go into the atria, it is prevented by sudden closure of the atrioventricular valve. This is a mitral valve, and this is a tricuspid valve. There is a sudden closure of the valve, and the blood should enter into the great arteries. That is the reason you can see the pulmonary semilunar and aortic semilunar valve are open. Right. So this is quite common sense also. You should just understand that during the diastole, the blood has to come inside, and the blood has to come inside. That means the one from where it can come from the atria. So atrioventricular valve should be open right now, okay? And during the systole, the blood has to pump out, and where it can go out. Can it go out into the atria? No. And therefore, atrioventricular valve are closed, and it should go out into the arteries. and therefore semilunar valve is open. Let's come back to this picture. So when the heartbeat begins by the first step, which is atrial systole. Atrial systole, I told you that atrial systole, ventricles are in diastole. At that time, ventricles are in diastole. Atrial systole is followed by the ventricular systole, Atrial systole lasts for 0.1 second and ventricular systole lasts for 0.3 second. 0.1 second, 0.3 second, okay? 0.3 second. So this is 0.3 plus 0.1, this is 0.4. And rest of the phase 0.4, rest 0.4 second, there is a joint diastole. I call it joint diastole, joint diastole. Joint diastole means both systole, both atria and ventricles are in diastole. Again, listen. Atrial diastole begins after the end of atrial systole. So from here, atrial diastole begins and atrial diastole comes till here. In the same way, ventricular diastole begins. Ventricular diastole begins from here. If anything is not clear, at that point you can tell me. I'll explain that. Ventricular diastole begins from here and ventricular diastole continues till the next beginning of next ventricular systole. So a chamber can be either in diastole or in systole. A chamber should be either in diastole or in systole. If it is in systole, okay, so the other chamber is in diastole. As you can see, atrial systole, so at that time ventricular diastole. If I make ventricular diastole by green color, if I show ventricular diastole by green color, okay, so ventricular diastole by green color, this is ventricular diastole. You can see after the end of ventricular systole, which ends here, ventricular diastole continues till the beginning of the next ventricular systole. This is the beginning of the next ventricular systole. In this duration, the ventricles are in diastole. Okay, you understood? And one more thing, the yellow color, the yellow line is actually showing, the yellow one is showing this one. Okay, so this is showing the atrial diastole. Once again, atrial systole over and then atrial diastole begins. Atrial systole over, atrial diastole begins, children. This is atrial diastole, and this continues till the beginning of the next atrial systole. As you can see that the nearly half of the cardiac cycle, both yellow and green lines are there. That means there is a joint diastole. That means for 0.4 second, there is a joint diastole. Can you see that there is any joint systole? No, there is no joint systole. But there is a joint diastole. Certainly, there is a joint diastole. The total duration of cardiac cycle, the duration of one heartbeat is 0.8 second. It's the average duration of one heartbeat. One cardiac cycle is 0.8 second. I told you that cardiac cycle is one heartbeat. So, okay. So when I say cardiac cycle, it means one heartbeat. One cardiac cycle or one heartbeat. And the duration of that is 0.8 seconds. Can anyone tell me by calculation how many cardiac cycles can be completed in 1 minute? How many cardiac cycles can be completed in 1 minute? Yeah, I'm just coming to you. Yes, I'm just coming to you back. Don't worry, beta. Yes, you are right. Nearly 72 cardiac cycles. That means how many heartbeats can be completed? 72, because cardiac cycle, heartbeat same. That means the heart rate, normal or average heart rate is 72 heartbeats per minute. The heart rate is 72 per minute. Okay. Once again, Sufia has asked one question. But just concentrate here. Just concentrate here. You'll get your answer, Pakka. You'll get your answer. Shape. Let's go to the shapes. I have to make some shape here. Can you see two lines, two circles here? Good. If you can see two circles, right, what next we can do is we can make straight lines as like this. So then we can make straight lines. Okay. So we'll do like this. Okay. So now you have got two circles. That means one bigger one and one smaller one. And inside that, you have got 8 parts of that. Okay, if I start something here, it means there are 1, 2, 3, 4, 5, 6, 7, 8. And if each of them represents 0.1 second, so each of them represents 0.1 second, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, and 0.1. That means the total duration of this complete circle is 0.8 seconds. 0.8 seconds, the total duration. That's what I'm trying to show here. Now, I will show systole by shading and diastole by unshading. That means if I shade it, it is systole. If I don't shade it, it is diastole. You know that the beginning of cardiac cycle, there is atrial systole. I told you the smaller one is atria and the bigger one is the ventricles. So this is showing the ventricles and the inner one is showing the atria. Okay, done. Now guys, I'll show the atrial, and this is the beginning. Let's make it beginning from here. This is the atrial systole. And what is the duration of atrial systole? 0.1 second. So I have shaded 0.1 second. Rest of the duration is atrial diastole. I am not shading, that means it is atrial diastole. I am not shading, it is atrial diastole. Now, coming to ventricle, when the atrial systole is over, exactly at that point when it is over, here, I am now showing the ventricular systole. The ventricular systole, it lasts for 0.3. So 1, 2, and 3. Shade the 3 of them. 1, 2, and 3 because it lasts for 0.3 seconds. Yes, we have shaded. Ventricular systole is shown by the shading of these oblique lines. For 0.3 seconds, ventricular systole. For rest of the remaining time, it is diastole because I am not shading. And obviously, if a chamber is not in systole, it is in diastole. Atrial systole is for 0.1 second, and that's the reason 0.7 seconds it is diastole. So if I just write atrial diastole here, so atrial diastole, it lasts for 0.7 second. In the same way, if I ask you what is ventricular diastole duration, what will you write? Ventricular diastole duration, come on, tell me. Duration of ventricular diastole. How much better? 0.5 seconds. Very good. It is 0.5 second. 0.5 second. Good. It is 0. How did you, how anyone can think of? 1, 2, 3, 4, 5, 0.5. Each one is 0.1. And atrial diastole, 1, 2, 3, 4, 5, 6, 7, 0.7. So this is how we can write the duration of diastole. And systole, so as very clearly seen, if I ask you atrial systole, you will say 0.1 second, and ventricular systole is 0.3 second. And this duration, that both atria diastole and ventricular diastole, so for half of the duration of cardiac cycle, ante for 0.4 second, 1, 2, 3, 4, for 0.4 second, there is joint diastole, right? So if I write here, joint diastole is 0.4 second. Joint diastole is 0.4 second. Are you guys okay with this? If you can understand these durations and when what step is over and when atrial systole is going on, ventricles are in diastole, and when ventricular systole is going on, atria are in diastole. And really, it is the greatest design ever for any pump or any pumping system, so that this delay has been maintained. Very meticulously, very intelligently, the nature, the Almighty has done, has made some arrangement in the heart wall that the delay occurs. To make this delay, there is a very important center being located in the heart, which maintains this delay. We'll understand about these electrical centers right now. For after knowing the duration, and now to understand the dynamics of the pressure, I have to now take you to the journey to understand the dynamics of the pressure. Now, this is my first halt of today's class, and I want you to tell me if anything or any confusion here. Rather than what shall I teach you more, you can just tell me whatever I have taught you so far, in that anything which is not clear. Okay, I'll do that. Okay, I'll do that. Mr. Handsome, I'll do that. No, don't worry. Tejaswini, one heartbeat is one love and one dub. Okay, so it is, yes, we can say that. Yes, cell cycle explain. King, beta, first you cardiac cycle understand. Exams are all compulsory, very compulsory exams. Cassell's intrinsic factor, beta, that is a factor which helps the absorption of vitamin B12, na? Absorption of vitamin B12. Yes, Nilesh, very good, very good. When all of you write 72, I was just smiling in myself that none of you have done the calculations, because it was just, nearly we can say 72. None of you have done the calculation, Manasa. Now your calculation, King, now your calculation is right. Priya, that's what I'm now going to tell you, love and dub only. That's the reason I have just stopped here. What I have to tell you is different thing. What I have told you, in that anything I want to emphasize, you can tell me. Bicuspid valve, because it looked like a mitra. But a mitra means cap. Pavan, mitra means cap. Time of ventricular systole, contraction, 0.3 second. Hasini, 0.3 second. It is written also VS, 0.3 seconds on the left upper corner of the board. And in the diagram also, you can see that for 0.1, 0.1, 0.1, these three of them I have shaded to show the ventricular systole. The outer circle is for ventricles. But a recording, we are doing it in some other computer. Another computer, we are doing the recording. बैटरी प्रॉब्लम उसमें आ रहा है कि बैटरी लो your battery is running low. You might want to plug क्यों नहीं किया अभी तक? In 10, we learned that atrial contraction is 0.11, 0.11. ठीक है बेटा, ठीक है. Actually, we are just taking up to 1 decimal only. Evolution in animals, sir. About brain once again, ठीक है बेटा. क्या ठीक है? क्या है शिवम? शिवम बेटा, ऐसा क्यों कर रहे हो बताओ? Battery low. This one, showing battery low. I think you have to plug this one.
Okay.
This chatting is, they are doing chatting among themselves also. Chatting is with the.
No, sir. Question for.
Okay, ठीक है. Okay, ठीक है. So very quickly, see Boyle's law. You will understand. You will be taught in a different. I think chemistry people will teach you Boyle's law in detail. I can just tell you the the relation between the ventricular pressure and the ventricular systole. Okay, so I can just tell you that. Come on, let us quickly see what all we have learned today. In today's class, we started with the cardiac cycle, the duration of cardiac cycle 0.8 second. Cardiac cycle or heartbeat. One cardiac cycle means one heartbeat. The different phases are atrial systole, ventricular systole, and joint diastole. Atrial systole 0.1 second, ventricular systole 0.3 second, joint diastole 0.4 second. Okay. Now, when atrial are in systole, the ventricles are in diastole. As you can see, the green one. We have done this better in another picture, right? So this one can be seen once again here. Now this picture can tell us better. This picture can tell us better, right? Atrial systole, ventricular systole, and joint diastole. So far points are clear. And duration of joint diastole. Why? Because they both are in diastole here, and systole is shown only by shading. Rest, the one is diastole. Now, just concentrate at this point. Just concentrate at this point. This is point number 1. At this point, if you concentrate, you will find that the ventricle systole is beginning. That means the pressure started rising in the ventricles. Pressure started rising in the ventricles. Okay. Now, when pressure starts rising in the ventricles, what is going to happen? The blood is trying to get inside the ventricles. The blood from everywhere tries to get inside the ventricles. Okay. Done. Again. Again, just one thing, just one thing. Direction of blood flow, we said na beta, direction of blood flow is already we have done from the blood from the great veins like the vena cava and the pulmonary veins to atria to ventricles, and ventricles to the great arteries. ये बेटा पहले ही कर लिया अपन ने, right? And what is preventing re-entry of blood into the ventricles? The aortic and pulmonary semilunar valve. What prevent the re-entry of blood into the atria? Atrio and ventricular or atrioventricular valve, also called the tricuspid valve. Okay. And what prevent the entry of blood into the veins, great veins? Actually, there is no valve at this opening, but veins have internal valves, and these opening, the veins are obliquely open. So when atrial systole occurs, at that time, the opening closes. So please understand first this point. Is this point clear? Done? ठीक है. This is nothing. Then direction of blood is clear to you. Once again, ventricular systole, ventricles are contracting, pressure inside the ventricle is rising. When the pressure inside the ventricle is rising, this blood is trying to go in every direction. When the pressure inside the ventricle is rising, the ventricular blood is trying to go in every direction. Where it should go? It should go in the great arteries. Yes. It should not go into the atria. No, it should not go into the atria. Who prevent the blood entry into atria from the ventricles? The closure of AV valve, atrioventricular valves, the tricuspid and the mitral valve. Okay. So here at this point, can I write that the AV valves, they are closed. The AV valves are closed. AV means atrioventricular, which means tricuspid and bicuspid, tricuspid and mitral. They are closed. They have to be very suddenly closed. They have to close with a buzz. They close suddenly. They close by making a sound, by making a buzz. And this happens when the pressure in the ventricles is rising. The ventricle blood tries to enter into the atria, but then the atrioventricular valve, they close. And where the blood is actually moving, see, where the blood is actually moving, the blood actually move into the great arteries. That means at this time, this should go on. That means the aortic and semilunar valve, they should remain open. The aortic and semilunar valve, so aortic and pulmonary semilunar valves, they are open. Aortic and pulmonary semilunar valves, they are open. Semilunar valves, SLV, semilunar valves, they are open, and atrioventricular valves, they are closed. And when valves close with a gush, just like when the door is closed, it makes a sound. But when the door is open, it doesn't make a sound. But if you close the door, that too with forcibly, the force closer will make a sound. At the point when the atrial systole is over and ventricular systole is beginning, at that point, we have put that mark there and AV valves close, SLV open. Dear children, I want you to concentrate at another point. Another very important point, and guys, this point is here. Also concentrate at this point. Now, what is happening at this point? Atrial systole is over, ventricular systole is over, and ventricular diastole is beginning. That means pressure in the ventricles is rising. That means pressure in the ventricles is rising. Sorry. I'm sorry. I said wrong. Okay. So at this point, ventricular diastole is beginning. That means pressure in the ventricles is falling. Please pardon me. Pressure in the ventricles is falling, right? And because of the falling pressure, you know that the diastole is a receiving phase. So blood from everywhere will try to come into the ventricles, okay? So from where it should come into the ventricles, once again, blood from everywhere should try to come into the ventricles because the pressure in the ventricle is falling, right? So in the ventricles, blood tries to come from the arteries as well as from the atria. Where it should not come, it should not come from the artery. So there will be closure of the semilunar valve, and from where it should come from the atria. There will be opening of the atrioventricular valve. Once again, concentrate at this point. Semilunar valves, they are closed now, and atrioventricular valves, atrioventricular valves are opened. AV valves are opened and semilunar valves are closed. So alternatively, it has happened. At that point, at this point, AV valves are closed. At this point, AV valves are open. At this point, SLV are open. At this point, SLV are closed. I again write here, AV valves, it means it means atrioventricular, and SLV, it means semilunar valves, okay? Semilunar valves. When AV valves are closed, they make a sound, and I call it S1. They make a sound, hard sound, I call it S1, sound 1. And when SLV are closed, they make the second hard sound, sound 2. Because you know that the closure of the valve make a sound, opening of a valve does not make a sound. Closure of the valve make a sound. So the second time the hard sound comes is at this point when the SLV closed. So for sound 1, AV valve closed, and for sound 2, SLV closed. Hard sound 1 due to closure of AV valves, and hard sound 2 due to closure of semilunar valves. Dear children, the hard sound 1 is also known as lub sound, lub. It is also known as lub. And hard sound 2 is also known as the dup sound, dup, also called the dup sound. So the reason for the hard sounds which are audible, lub and dup, sound 1 and sound 2. Sound 1 comes because the AV valves are closed, and for sound 2, the SLV are closed. Now this we have to actually learn it. We have to learn it very hard, that for sound 1, which is also known as lub, the reason for sound 1 is sudden closure of AV valves, and reason for sound 2, which is also called dup. The reason is sudden closure of semilunar valves. Sudden closure of semilunar valves. This is my second halt in today's class. Please make sure you understood this. The blood should move from the veins into the atria, from the atria into the ventricles, from the atria into the ventricles, and from the ventricles into the great arteries, right? From the great veins into the atria, into the ventricles, into the great arteries. The blood from the ventricles into the atria is the right direction, but to prevent the wrong or return back, this is prevented by semilunar valves. The return is prevented by semilunar valve. In the same way, from the ventricles to atria, if the blood tries to return from the ventricles to atria, it is prevented by sudden closure of the AV valves. Atrioventricular valves. The two atrioventricular valves I write here. I'll make this here. The AV valves. There are two AV valves. One is tricuspid on the right side, and mitral on the left side. The semilunar valves, again, there are two semilunar valves are there. One is the pulmonary. Semilunar valve. This is on the right hand side. And one is the aortic semilunar valve. This is on the left hand side. Aortic semilunar valve, left hand side. Tricuspid on the right hand side, and mitral on the left hand side. Two AV valves, two SLV. closure of the AV valves. This makes, if this closes, it makes sound 1, and if this closes, it makes sound 2. Sound 1 is also called lub. Sound 1 is also called lub, and sound 2 is also called dup. Sound 2 is also called dup. We have to batti go to this. And see, why batti go to that? We can learn the answer so that in the examination, we may not think the logic behind it. Because in 45 seconds, we have to read the question and write our response. We have to blacken the right circle. And that is the reason it should come on your tips rather than you think and try to get the pressure differences and all. But it can only be learned, it can only will be mugged up, or it can only come on the tongue when you think of the pressure difference many times. So while learning, while reading, while preparing, think the logic, but in the examination, give the reflective answer. But while preparing, think the logic. And the logic says that atrial systole, atria blood should go into the ventricles. Good. And there will be opening of the AV valve. Ventricular systole, ventricle blood should go into the arteries. There is an opening of the SLV. But now coming to the atrial diastole, the blood in atrial diastole should not come from the ventricle because of the closure of the AV valves. Again, ventricular diastole, the blood from the arteries cannot come back into the ventricle because of the sudden closure of the semilunar valves. Now, these points, this point and this point, you can just think of these points here. So one is this point and one is this point you can think of. Right. Now here what is happening? The atrial systole is over, okay? And the ventricular systole is beginning. At this point, you can see atrial systole is over, ventricular systole is beginning. Now, ventricular systole means pressure in the ventricle is rising. Ventricle blood should go into the arteries. Therefore, SLV open and ventricular blood should not go back into the atria. And that is the reason AV valves closed. Coming here, ventricles are beginning their diastole. Ventricular pressure is falling. So the blood should come into the ventricles from the atria. AV valves open, and blood should not come into the ventricles from the arteries. Blood should not return into the ventricles from the arteries. Therefore, SLV closed. Semilunar valves are at the opening of the arteries, and AV valves are between the atria and the ventricles. Dear children, come on. Now your doubts. Now your doubts. AV means atrioventricular. Oxygenated or deoxygenated, it's a different thing, beta. Abhi, a difference between atria and arteries. Good question. Good question. Atria and arteries. Atria means the chamber. Atrium, plural, atria. Arteries means the pulmonary artery and systemic artery. Pulmonary artery means pulmonary trunk, because it gives rise to pulmonary artery, and systemic trunk or aorta, which give rise to so many arteries. Okay, so atria is a plural of atrium, and arteries are the vessels. Arteries are the vessels. Okay, so shall we write here? Okay, shall we write here to avoid the confusion? I'll write here. Okay, I'll write here. Atria is a plural of atrium. Atrium, which is a chamber, heart chamber, and arteries is a plural of artery. And what is artery? It is one of the blood vessels. Artery means a blood vessel. blood vessel, thick walled blood vessel, artery. Atrium, chamber, artery, blood vessel, atrium, chamber, atria, plural of atrium, arteries, plural of artery. You understand? You understand these terms? Any other doubt? I can see the genuine doubt and I'll answer. Aorta gave rise to systemic trunk. Actually, aorta and systemic trunk both are same. Aorta and systemic trunk both are same. Okay, systemic trunk and aorta same. Okay, again, I'll make it clear. I'll find out some place for it. We have filled this one. Can we write here? Aorta and systemic trunk. We cannot write. Okay, so I'll come to this one only. Okay. Dear children, aorta is same as systemic trunk, and the other one is pulmonary trunk, is same as pulmonary aorta. Which term is more commonly used? Here, aorta is more commonly used. Pulmonary trunk is more commonly used. Aorta and pulmonary trunk is more commonly used. It should be remembered that the pulmonary trunk gives rise to pulmonary arteries. So what is the difference between pulmonary trunk and pulmonary artery? Okay, I'll write here pulmonary trunk divides into two pulmonary arteries. Two pulmonary arteries, like the right pulmonary artery and the left pulmonary artery. The right pulmonary artery and the left pulmonary artery. The right pulmonary artery and the left pulmonary artery. The right pulmonary artery is going into the right lung and the left pulmonary artery is going into the left lung. So pulmonary arteries both arise from pulmonary trunk. So pulmonary trunk, like this, divides into two pulmonary artery. So this is pulmonary trunk. This is right pulmonary artery and this is the left pulmonary artery. Okay. Once again, we'll go back to the whole class. We'll see the whole class once again very quickly. We'll go back, come on, starting from the starting. The starting of the class is this diagram. And in this way, case, Boyle's law is just, I mentioned the name, no need to go. This is all, this will be done in the chemistry. Right now, in systole of the heart, systole means contraction, diastole means relaxation. Systole means contraction, and diastole means relaxation. Okay, relaxation. Okay. This is one point. In systole, contraction of the heart muscle takes place. Therefore, the chamber constricts. In diastole, relaxation of the heart muscle takes place. Therefore, the chamber relaxes. During systole, the blood comes out, blood leaves the chamber. And during diastole, the blood enters into the chamber, okay? During systole, the blood pumps out. And during diastole, blood pumps out of the chamber. During diastole, blood pumps into the chamber, or blood enters into the chamber. The normal duration of cardiac cycle is 0.8 seconds. One cardiac cycle is same as one heartbeat. The various duration of the heartbeat are these, okay? Atrial systole, ventricular systole, joint diastole, and this occurs in this in this direction, okay? During systole, the pressure increases. During diastole, the pressure decreases. During systole, pressure increases. During diastole, pressure decreases. During systole, pressure increases. During diastole, pressure decreases. And that is the reason blood is pumped out during systole, and that is the reason blood enters into during diastole, because the pressure decreases and therefore blood enters. The rule of thumb is blood moves from the region of low pressure to the region of high pressure. The rule of thumb is blood moves from the region of low pressure to the region of high pressure, low to high, low to high. The rule of thumb. Next one, it says, now in this one, we have clearly make you understand that there can be a joint diastole, but joint systole is not there. And there is an alternate systole. That means during atrial systole, ventricular diastole, and ventricular systole, atrial diastole. Okay, and this picture also gives the correct duration, that ventricular diastole is for 0.7 seconds and atrial diastole is for ventricular diastole is for the atrial diastole is for 0.7 seconds and ventricular diastole is for 0.5 seconds. Okay, and joint diastole is for 0.4 seconds. We have also understood that at this point, when the ventricular systole is beginning, ventricle pressure is rising, the blood tries to enter into the arteries. And this occurs due to opening up of semilunar valve. And the atrioventricular valve is closed so that the blood may not enter into the atria. The blood is prevented to enter into the atria due to closure of the atrioventricular valves. Is the point clear? What's the duration? The class was from 3:30 to 4:30 or 3:30 to 5 o'clock now. Why is the joint diastole 0.4 second? Do arteries also have valves? No, arteries do not have internal valves. Okay, thank you, Gautam. Arteries do not have internal valves. Bicuspid valve. Bicuspid is same as mitral. So we are not writing bicuspid, we are writing it as mitral. But you can also ponder upon it. You will be given these. You can also download these. I'll give the QR code. You can download these pages and you have to ponder upon it. See, it is not that directly the first one, that so 100% clarity occurs. If you are reading it for the first time, obviously it will take little time for the knowledge to settle in your brain. So you have to let this knowledge settle. What you have to continuously do is to learn the intention, the try. You have to keep on trying and let this knowledge settle down. For that, Internally, you have to become silent, and this knowledge should settle down. Let it settle down slowly and slowly. Let it settle down slowly and slowly. For example, if you when you go to the first to a new place for the first time, like when I came here for the first time, it was such a new thing for me because I cannot read any symbol or anything written. So I was only going through the symbol. So I was learning the places. If anything, I read it in English, it was something miracle for me. So whatever I read in English, any board sign or anything, I was keeping that thing in the mind, but it was very difficult. The real map was not very clear for me. Slowly and slowly, the map started settling in my brain. Now the rastas, the directions are settling into the brain. In 2 years, good amount of directions are settled. So at least where I'm living in that area and the nearby areas, those directions are settled in my brain. You know, it takes time, right? And slowly, more and more directions. Now the adjoining areas and the whole city, the main city parts, their directions are now settling into my brain. In the beginning, what was in our favor was just the Google navigation. So I understood that in the beginning, I was just going from point to point, right? I remember that the first time I start driving, I was living in a place called Band Circle, nearby Band Circle, a hotel near the Band Circle. And from that Band Circle, I have to drive to my previous company, the Goshala. I have to come to the Goshala. So during the whole passage, the only thing which I can read was go slow. The only thing in English was go slow. And remaining everything was in the local language, which I couldn't. I mean, still today also, it was total jalebi for me. I cannot understand that. I can just understand little bit audio, little vocal language, but the script is still not absolutely. I am zero in the script, right? Because I did not try it. I never tried it. I never intended, but I tried to learn the spoken language, right? So that I'm getting spoken language, I'm getting script, I never tried. You understand? So in the beginning, you have to make points on the map. In the same way, you have to make points here. And slowly, the real directions, the nuances, the intricacies, the complexities will try to settle in your brain. Okay? So once again, when the pressure is increasing, the blood is entering into the arteries and therefore SLV open up. And when the pressure in the ventricles is decreasing, the blood from the atria should come into the ventricle. Therefore, atrioventricular valves are open and blood from the arteries should not go back into the ventricle. Therefore, the semilunar valves are closed. Okay, done. Next one. Next one was when the semilunar valves are closed, it leads to the sound 2, and when atrioventricular valves are closed, it leads to sound 1. Sound 1 is due to sudden closure of the atrioventricular valve, and sound 2 is due to sudden closure of the semilunar valve. Semilunar valve, sound 2, atrioventricular valve, sound 1. Sound 1 due to sudden closure of atrioventricular valve, and sound 2 sudden closure of semilunar valve. Sound 1 can also be written as lub, and sound 2 can also be written as dub. Okay. Again, the direction of the blood is from veins, the great veins into the atria. From atria means both the atrium, right and left atrium. Atrium plural, atria. From the atria into the ventricles, okay? And from the ventricles into the arteries, the great arteries. Which arteries? Great arteries. What are the great arteries? pulmonary trunk and aorta. Great arteries. These are the great arteries. Example, pulmonary trunk and aorta. Pulmonary trunk and aorta. These are the great arteries. Okay. And veins. Which veins? The great veins. The great veins. The vena cava and the pulmonary veins. Vena cava and pulmonary veins. The return of the blood from the arteries into the ventricle is prevented by sudden closure of semilunar valve, and the return of the blood from the ventricles into the atria is prevented by sudden closure of the AV valve. Okay, okay, I have some more tricks to make you understand, but then I'll first quickly complete all these 5 slides. So the 2 AV valves are tricuspid and mitral, and the 2 semilunar valves are right side pulmonary semilunar valve and the left side aortic semilunar valve. Okay. So the 4th page, it says again the direction is given, direction from the veins to the atria, atria to the ventricles, ventricles into the great arteries. From atria back into the great veins, it is prevented by, because the reason why the blood does not return back into the great veins. The reasons, number 1, veins have internal valves, and reason number 2, the veins have oblique opening in the heart valves. Heart walls, diwar, wall. Okay. Again, from the veins, from the ventricles into the atria is prevented by a sudden closure of atrioventricular valves such as tricuspid and mitral valve, and from the arteries into the ventricle is prevented by sudden closure of the semilunar valve, SLV, the pulmonary semilunar valve and the aortic semilunar valve. Okay, atria, plural of atrium, arteries, plural of artery. Artery is a blood vessel, atrium is a heart chamber. What is here, guys? Aorta is also called the systemic trunk, and pulmonary trunk is actually or also called pulmonary aorta, pulmonary trunk. Pulmonary trunk give rise to right pulmonary and left pulmonary arteries. Pulmonary trunk give rise to right pulmonary and left pulmonary arteries. Okay. Pulmonary trunk divides into 2 pulmonary arteries, the right pulmonary artery and the left pulmonary artery. This is a diagram. The right pulmonary artery and the left pulmonary artery. Dear children, I have again quickly review all these 5 slides. We have one more day, and yes, we have the full time with us. Okay, when will physics classes start? QR code. Okay, beta. Let's take the QR code very quickly. Let's take the QR code. And that's all from my side. My time is over. I'll give the QR code, and please, for God's sake, like yesterday you have shared, today also, please share what you can scan. Please share that to me, and you have my number 988-717-3335. And yes, I am Anurag Verma signing off from this class. God bless you. Bye-bye. Take care. All your doubts in the next class. All your doubts in the next class.